Now we are discussing one of the important transducer, that is a strain gauge. As the name represents, it measures the strain and stress in the materials. It is a passive transducer. We discussed already what is an active transducer. It does not require any external power source, whereas a passive transducer requires external power source. And it converts mechanical displacement into change in resistance. Whenever the mechanical displacement is changing, accordingly the resistance is changing. Mainly we use a wire, that is a normal wire which is having a resistance. Every material is having resistance in the universe. When the wire is stretched within its elastic limit, when the wire length is increasing, then the resistance is increasing. So here we are taking the strain wire and we are fixing this strain wire to a structure along with a cement. So when the strain is applied to the structure, this structure either contracts or expands. This structure is connected to wire, thereby affecting the wire. Whenever the wire is increasing its length, then resistance is increasing. When the wire length is decreasing, compressing, then the resistance is decreasing. So we measure this by using the gauge factor. Gauge factor is nothing but change in resistance per change in length. Fractional change in resistance to fractional change in length. If I am changing how much length, how much resistance is being changed, that can be known by using gauge factor. A very good strain gauge should have a very high gauge factor. Very high gauge factor means very high sensitivity. Generally, metallic strain gauges, they have thermal effects and they are brittle. That's why we generally go for the semiconductor strain gauges. Semiconductor strain gauges have 50 to 60 times higher gauge factor than the metallic gauges. Here we have given a sample diagram. This is the semiconductor material, either we can use germanium or silicon. We have taken for electrical connections requirement gold leads, because gold is very good conductor. And this is the base on which we are keeping this semiconductor material. So this semiconductor material has thickness 0.05 millimeters and it is bonded to a material like insulator Teflon. These are the electrodes. Now this type of strain gauge along with our IC741 op amp, we can use as a pressure sensitive transducer. Pressure sensitive transducer means whenever there is a change in pressure, this strain gauge along with IC741 measures that and it converts into electrical signal. This semiconductor strain gauge has very good stability and thermal sensitivity also good for this semiconductor strain gauge compared to metallic gauge. These are the characteristics of the strain gauge. This is normally doped and this is heavily doped. Now, when the semiconductor is normally doped, on the right hand side we have tension, means length of the wire is increasing. On the left hand side we have compression, means length of the wire is decreasing. When the length of the wire is increasing, the resistance is increasing but not linear. When the length of the wire is compressing, then the resistance is also changing. These characteristics are not linear. But when the semiconductor is heavily doped, then it is appearing like linear characteristics. When tension is there, then dr by r, change in resistance, per original resistance of the material, how much resistance is changing compared to its original resistance. Those with respect to those characteristics we are representing here. Advantage of this strain gauge is semiconductor strain gauge. It has very good gauge factor, already we discussed, and lifetime with this semiconductor strain gauge will come for longer amount of time, and for the high frequency response compared to metallic strain gauge we go for the semiconductor strain gauge. The size of the semiconductor strain gauge also is very much less. It occupies only small amount of space, and it is very sensitive because it is having very good gauge factor. But disadvantages are, it is expensive compared to metallic strain gauge, and even though we are saying compared to metallic strain gauge thermally stable, but it is also being affected by the temperature. And the applications we use whenever we want to measure the stress and strain of any material, we use this, and mainly in the industries. Example, if a particular material can carry the weight for 1000 kilograms, after that if we give, it will break. So at that time it will measure how much stress is there in that material for the 800 kilograms, like that we can measure. And we can measure the strain of the material in different environments. How the strain of the material under the ocean, how the strain of the material in Sahara desert, how the strain of the material in Antarctica, or how the strain of the material in normal environmental conditions, that can be measured. And in high temperature environments also we can use, like jet engines and turbine blades, and in rocket fuel at the time to measure the strain of that particular rocket or turbine blade or jet engines, we can measure that one. So in aircraft generally, when the aircraft is flying in the air, it is required to measure the strain. The environment is putting much pressure on it. So by overcoming that pressure, the flight is going. So how much strain the aircraft is having, that will be sent from the aircraft to the ground station by using the strain gauge. And similarly, for the temperature, pressure and acceleration measurements, we will use the strain gauge. And in medical department, suppose a person accidentally, he was hit by something, but in X-ray if we see, there is no fracture, but he is having much pain, or for animal legs majority of the time. So how much strain is there in the bone or human skull? Strain means not that which you are studying, that strain, not mental strain. We are calling about the physical strain. How much strain is there on the skull, and how much strain is there on the human bones? You know, the brain, even though the surgeons can do operation for the brain without anesthesia, because we will not feel pain. So brain skull, to know the strain, how much strain it is having, for animals, for elephants or buffaloes, legs, their legs, how much strain, because they are generally, if they see something harm is coming, they fastly try to run, but they are not habituated. They are like dogs or horses. They might not go with that much speed. Suddenly when they want to go, their weight is much. Elephant weight is much, buffalo weight is much. Their legs cannot carry that much weight in that much short time. At that time, their legs they may get cramps in their bones. At the time, to know the strain of the bones, we will use the strain gauge in the medical department. Okay, mainly strain gauge is used to measure the strain in the materials. It is nothing but it is measuring the resistance change. Whenever there is a change of this wire attached to that particular structure, when the structure is being compressed or expanded, accordingly the wire attached to it is changing, expanding or contracting. So this is how we use the strain gauge.